66 million years ago, the Earth was stable. For over 150 million years, a vibrant, thriving ecosystem had dominated the planet. Massive herds of triceratops roamed the plains, while armored herbivores lived in the forests. Ruling over it all were apex predators like the Tyrannosaurus rex. It was a world of giants, deeply entrenched and perfectly balanced. Within days, that 150 million year dynasty vanished entirely. This sudden collapse left a profound geological scar, one that humans would spend 66 million years deciphering. The investigation began in 1980, when a team of scientists, led by Luis Alvarez and his son Walter, started examining ancient rock formations in Italy. This chart illustrates their discovery. Embedded in the rock is a thin, dark band of clay, known as the KPG boundary, which marks the transition point where the dinosaurs disappear from the fossil record. When they tested this layer, they found a massive spike of an element called iridium. Iridium is exceptionally rare on Earth's surface because it largely sank into the planet's core during formation. However, it is common in space rocks. Finding this global layer provided physical evidence of a massive impact event. For decades, the scientific community focused on a specific origin point, a rocky asteroid that had drifted out of the main asteroid belt between Mars and Jupiter. But later tests on the actual impact site in Mexico revealed a chemistry that didn't match the asteroid belt at all. The source of the catastrophe remained a mystery. This satellite image shows the Yucatan Peninsula, the site of the 150-kilometer-wide Chicxulub crater. To identify the object, scientists drilled into the ocean floor to extract rock cores from deep beneath the surface. Analysis of the samples revealed the object was a carbonaceous chondrite. This specific classification describes rocks that are rich in carbon, water, and amino acids. These wet, carbon-rich rocks are virtually non-existent in the main asteroid belt. They are formed in the extreme cold of the outer solar system. This chemical profile points toward a long-period comet, an icy nomad originating in the Oort Cloud, at the furthest edge of our solar system. A comet in the Oort Cloud rarely enters the inner solar system on its own. This fragment likely had assistance from Jupiter. The planet's powerful gravity can redirect passing objects, acting like a slingshot. Simulations suggest Jupiter's pull sent this comet toward the Sun. As it neared the star, tidal forces shattered the icy mass into pieces. One fragment, larger than Mount Everest, intersected Earth's orbit. It entered the atmosphere at 72,000 kilometers per hour, compressing the air until it turned into white-hot plasma. It struck the coast of Mexico with the force of 100 trillion tons of TNT. The impact vaporized 30 kilometers of the Earth's crust in an instant and sent shockwaves that triggered magnitude 12 earthquakes across the globe. The immediate fireball destroyed everything for thousands of miles, but the global extinction of the dinosaurs resulted from the environmental decay that followed. Vaporized rock and sulfur filled the atmosphere, creating a global layer of aerosols that blocked the sun. Global temperatures fell below freezing, leading to a decade-long impact winter. This fossilized triceratops represents a class of animals that required immense daily plant intake. Without sunlight, photosynthesis failed. The forests died, and the large herbivores starved. The oceans experienced a similar collapse. Acid rain dissolved the shells of plankton, which form the base of the marine food chain. When the plankton died, apex predators like this mosasaur had nothing left to eat. The fireball ended life at ground zero, but the worldwide disappearance of the dinosaurs was a consequence of the ensuing environmental decay. Cold, darkness, and hunger erased 75% of all life. With the dinosaurs gone, the planet was wide open. This created a land of opportunity for the small, burrowing mammals that had survived the impact winter. Through a process called adaptive radiation, these mammals rapidly evolved. They grew larger and filled the ecological spaces left empty by the extinction. This evolutionary path eventually led to humans. If Jupiter had not redirected that comet 66 million years ago, our species would likely not exist. We were born from a cosmic accident, but we are no longer passive targets.
Today, we scan the sky and test technologies to deflect incoming objects. For the first time, a species on Earth has the ability to write its own future.